Meet Jennifer. She is a parent just like you. She is frustrated because this is not how she learned math. She decided she could not help her child because students should use strategies based on place value, properties of operations, the relationship between addition and subtraction. What? Well, place value refers to understanding our number system is a base 10 number system. The value of the digit is dependent upon its place in the number. Below is a base 10 model. As you can see, 34 equals 3 groups of 10 or 30 plus 4 ones. When adding and subtracting, students can use their knowledge of place value to decompose numbers to make them easier to compute. When students subtract 80 minus 30 rather than 8 minus 3, they are maintaining the value of the number, which reinforces the magnitude or size of the numbers with which the students are working. Maintaining the value of the number helps students evaluate the reasonableness of their answer. Although subtracting all numbers as if they are ones may seem easier, it creates long-term problems. It can stunt students' understanding of our base 10 number system, and it can cause interferences as students begin to work with both larger numbers and decimals. All of the subtraction strategies that will be shown maintain the integrity of the magnitude of each number. The strategies reinforce place value understanding as students advance to operating with larger numbers. Students should use strategies based on the relationship between addition and subtraction. The relationship between addition and subtraction is based on part-whole relationship, meaning if you have the two parts and you add them together, you will get the whole. If you have a whole and you subtract a part, you will be left with the remaining part. The relationship between addition and subtraction. When the whole is known, the student may count on from the known part up to the whole or subtract the known part from the whole. Let's look at some strategies students may use to subtract. Counting back strategies. This is a base 10 model. The student drew the minuend, which is the first number 55. They removed or marked out the subtrahend, which is 26, and they were left with the difference, which is 29. This can also be accomplished on the number line. The number line is a flexible model students can use to help them keep track of their count as they subtract. In this example, the students started with 55 and they counted back 26 or took away 26, which landed them on 29. In this example, the answer is the number they land on, which is 29. They may also take away a whole group of 20 to be more efficient. The difference model looks different. The student will start at 55, the whole, and they will count back to the known part, 26, to find the difference between 55 and 26, which is the other part. In this example, the answer is above the hops. Counting on strategies use the relationship between addition and subtraction. The student takes a subtraction problem and turns it into a missing add-in. For example, what do I add to 26 to get 55? So the student will start at 26 and they will count up to 55. In this example, the answer or the difference is above the hops. Break apart. This looks most like the standard algorithm, but it does maintain place value understanding and the magnitude of the number. In this example, they broke the numbers apart by place value. Then they took 10 away from the 50 and they added the 10 to the 5. So now they have 40 plus 15 minus 20 and then minus 6. Partial sums. This is when a student breaks apart the subtrahend into its place value. The student will subtract 20 to get 35 and then subtract 6. This is a very efficient method of subtracting and is commonly used in second grade. Make it friendly is a strategy that is commonly used in third grade and with some second graders. What it means is that we can make the numbers friendly as long as we add the same amount or take the same amount away from both numbers. We are just shifting the numbers on the number line without changing the distance between the numbers. In this example, we added 4 to both numbers to get 59, take away 30. That is a much easier problem to work with. Another way students may make it friendly is only take what they need away from the subtrahend and then do the same to the difference. So in this example, they took away 1 from the subtrahend to make it 25. But then they had to take the same amount away from the difference to get the answer. Negative numbers is something that is probably unfamiliar to most parents. It is not commonly used in elementary school, but some students who understand negative numbers may choose to use this strategy because it is highly effective and highly efficient. In this example, the student subtracts 20 from 50 to get 30, but when they subtract 6 from 5, they get negative 1. So then they subtract the 1 from the 30 to get 29. Subtraction strategies require place value understanding and an understanding of the relationship between addition and subtraction. Now, Jennifer has the tools she needs to help her child with math.